Welcome back to Science, everybody. Today in our Forces, Fluids, and Density unit, we're doing an introduction to a concept called, if you can read this, if I can get it written down here, density. Okay, an introduction to density. Now, in this lesson, we're going to be going over mass, volume, and weight, and because we need to know those to understand what density is. So first off, mass. Let's start out with mass. Now, what mass is the amount of matter in an object. So the more matter is in that object, the more mass they have. So when we deal with mass, for instance, I have more matter in me because I'm just a larger person. I have more matter in me than my daughters because they're much smaller than me. So therefore, I have more mass. But if we move on to this concept of weight, is the force of gravity on an object. So if the more mass you have, the more weight you have, because inside of me I have more mass. I'm just bigger and taller, and I have more bigger organs, bigger muscles than my daughters. So therefore I have more gravity, more force pulling down on me. It pulls down on me more because I have more mass. So therefore I am heavier. So the amount of mass you have, the more mass you have, the more gravity has to pull down on you, and therefore the more weight you have. And the next concept, which is volume. Volume is how much space an object takes up, which we know this from math this year. So again, to reiterate, mass is the amount of matter or matter in an object. The more matter you have in an object, the more gravity can pull down on you. So therefore, the more weight you have. And the more and volume is how much space an object takes up. So when we're moving on to the next section, volume. We're going to look at how to measure things. How do we measure volume? Now, in measuring volume, volume of a rectangular prism is pretty simple. It is length, you guys should know this, times width times height. So if we have our rectangular prism, we have width, we have height, and we have length. If this was 4, this was 1, and this was 2, it'd be 4 times 1 times 2. 4 times 1 is 4, times 2 equals 8. And when we're dealing with volume, it's units of measurement cubed. So let's assume this was centimeters. We have centimeters cubed. So that is how you do the measurement of volume of a regular rectangular prism. Okay. The rest of this is for the rest of the measuring volume of cylinders and such. That's more when we deal with that in math. Now, the next concept is measurement of volume of an irregular object. Now, this is something called displacement. So, if I were to take this little T-Rex guy right here, this little guy, and I were to put him in this jar, this beaker of water, I'm going to put him in there. It originally started off as 4.8 right there. That says 4.8 milliliters. 4.8 milliliters of fluid. That's what was originally in there. But once you put this little T-Rex inside this beaker, then you notice that the volume of the water goes up because this T-Rex takes up some space in there. It takes up a certain amount of space. And however much space that takes up, that's how much the water goes up. So it goes up to 5.6 milliliters. So therefore, to figure this out, the volume of the T-Rex of an irregular object is the difference between 5.6 and 4.8. So you take 5.6, subtract 4.8 from that, and your answer should be 0.8 milliliters. So the volume of that T-Rex is 0.8 milliliters, and we know that because it is the amount of water that was displaced or put out of place, that was moved when we put that T-Rex into that beaker. Now we're moving to density. Now, quick thing on density. Density is a calculation of how much matter is contained in a space. Okay? So density is based on that. We know density is two things. It's mass and volume, because mass is the amount of matter in you, and volume is the amount of space something takes up. The amount of matter in you right here, how much matter, I'll get a different color so you can see how much matter is in you, and the amount of space. So here we're dealing with mass, it's the amount of matter in an object, and the amount of space something takes up is volume, the amount of volume in an object. So we know that density deals with these two concepts. So we need to somehow utilize these two concepts in a calculation to calculate density. And so the formula to calculate density is mass divided by volume would equal density, or density equals m over v. So if I were to choose some irregular objects, let's say the mass of me is, or the mass of that, say that T-Rex is 4, density equals, the mass is 4 grams, and the volume is 2 milliliters. Now we know that, just assume the T-Rex, that's how much it weighed, 4 grams, and it displaced 2 milliliters of water. So the density of that T-Rex would be 4 divided by 2 would be 2, utilize your first thing here, grams per milliliter. So the density is of the little T-Rex, assuming it took up 2 milliliters of space and it weighed 4 grams, would be 2 grams per milliliter. Okay? And we know this deals with floating and the concept of buoyancy, which we'll be doing next. Now, buoyancy, with that, buoyancy is effectively floating. But so if something floats on top of something else, it is less dense or has more matter in the space of the matter. So in other words, to put this in simpler terms, if something has less matter, so water has a certain amount of matter in it, right? And say that little T-Rex has less matter in it than the water, then it will float on top of that water because it's not heavy enough, not enough gravity pulling it down to go down through the water. If the density of the water and the T-Rex are the exact same, then it would be neutrally buoyant. Then it would not go up or down, because if it has less matter in it, then it would float up. More matter, it would go down. The same matter, it would stay suspended in the water. It would just kind of float neutrally in the middle of that water, because the mass is the same amount of matter, so it has the same mass. But if it has far more mass, such as a rock has more mass than that water, therefore it is more dense than the water, and it would sink to the bottom. An example of something that is less dense than water would be a small piece of wood. Wood is less dense than water, so therefore it floats up to the top, is positively buoyant. And if it is neutrally buoyant, something that has the exact same amount of density as the water, say a submarine in some cases, or a fish, it can float right in the middle. And if it has less or more density in the water, it will sink. So those are some examples of how density affects the buoyancy of an object. All right. So here's using particle theory. We know that particles are really close together in a solid, a little further apart in a liquid, and tons of energy and moving all about in a gas. So if we use particle theory to explain our answer, how does temperature affect density? Well, if we look at these particles, they're really close together. So in this particular object, it has a lot of matter in there. Therefore, it has more mass, and they're really close together, so it is more dense. So therefore, this would be more dense. And this one, they're further apart right here. So therefore, they would be less dense. There's less matter inside that object. Whereas this one, they would be middle dense, so almost neutrally buoyant. For example, a rock has a ton of matter within it, a ton of particles within it, and they're really close together, so therefore it is more dense. It sinks. A gas, such as air, if you were to blow water in a pool, those bubbles would rise to the top because they are less dense than the water itself. But if you have something that has, for instance, you can float on top of the water, but if you blow out all of your air, you might, so you might sink. You might sink a little bit because you're creating less density. And that is a quick summation of what density is for your lesson.